In this chapter, I will set up the Venom solver and start a cloth simulation. I will do like a glue in this area, on the top area, and the hands for these pieces to blend it together. I like to make this a bit static or bend to anim, or hold these pieces together at the bottom part of the belt, and I will have like more freedom at like uh, the bottom part here and the cloak area. So these will be more freely moving, but this area across the chest, sorry, and the belt, uh, all glued together and holding to each other. Okay, so I'll start selecting like this shoulder armor and the cross belt, and like the shirt, and this will be the group, and this part, these will be the target. So these pieces will be glued together, and for example, we don't like to have anything at this area, so this should not be in the group. Okay, this is looking good, and we have to decrease the search distance 0.005, for example. Yeah, this is looking good. I will increase the constraint by point to 5, and we'll see how this goes, and maybe we can increase it a little bit, but let's do the first simulation and see how it goes. Okay, so the next thing will be, let's cut these lines because we have to point deform this constraint proxy with the original animation. Okay, I will add a point deform, and this will be piped to the rest point, the rest pose, which is the first frame, and this goes to the animation. Let's do some organization. Okay, I will reduce the radius here 0.001, and we have to use a piece attribute, which is the path. So, for example, this piece will be deformed by the same path piece, like this. So this way we have like a good looking deformation because each piece will be deformed by the original piece. Okay, I think this is looking good for deforming the original geometry. And after that, we have to calculate the velocity. Velocity approximation, central difference, evaluate within frame range, and I will add attribute copy to also deform the constraint. This is not important. You can use it or not as you like, but we are deforming the constraint with the position from the geometry. This like will make the constraint follow the geometry. If you don't do it, it will stay at the origin. So it's not a big deal, but you can do it. I will add a Venom constraint at the end. Pipe this velocity and the constraint. I will use a pin to target, pin to anim, match animation, soft constraint, and this will be none, and the stiffness will be 0. We are using this for velocity blending. We will take the velocity from here and we'll blend it with velocity blending. This will help when you have a geometry traveling like a fast movement. This will tell the solver in which direction you are going and will have like a better result in the solver. So I will use for now 0.1. So we give it like 0.1 velocity, direction, guide, and the solver will have like 0.9 freedom to do the calculation. If you increase this if you increase this to 1, it will try to follow the velocity like a fully like a blended to anim. But this way you have, if you have like a fast movement, you can go 0.5. This will try to blend between the solver calculation and the velocity which is coming from the the movement, the one we calculated here. So with this way you can use like some fake movement stuff with adding color noise, and this will lead a different result. But this, like for example, if you have a cave and or this clock, you will have like a waviness on that based on this noise. So this velocity blend, you can use it in smart ways and you will have a different result based on what you need. And I will pipe this to the solver, and we have here what we did from before is the collider. I will take the one we did with the subs and pipe it directly into the solver. Before we pipe it, I like to add a soft peak and I like to animate it. So in the first frame, we have a collision group, what we did from before. And the first frame, minus 0.005. So this, if we have like intersections between the collider and the cloth, this will have some gap. Just let me show you the gap, what we will have. If we template this, we'll have like this amount of gap will help to prevent any intersections. If you have intersection with the cloth at the first frame, and we animate this like in the first frame, and let's go to the 8th frame, and we move it back to 0. So this way we'll have at the first frame a soft peak here. So this will try to prevent any intersections or interpenetration. Okay, this side for the collision, and for the solver itself, we have to increase the substeps, and the gravity is good. We'll use reduce a little bit the wind drag and use some velocity damping 0.005 or 0.01, and this one 0.05, sorry. I think these are good values for start. We can go like for 0.05 also, or we can now 0.025 for example, and okay, I want to double check the constraint iteration. I think we should go a bit like 150 for the collision passes. Let's go to 15 and increase the substeps to 4, because we have like a multiple amount of layers here. If we can go to 5, the layer shock will be even better. And post collision passes to 4 for now, and I will add a file cache. Load save cache, and rename this. Okay, let's cache it and see how it goes. Okay, I wanted to mention something before we continue. I stopped the simulation because this intersecting with each other. I wanted to move this as out from each other. So what I did, I added a soft transform, and I moved this a little bit out, and also this area. This one we have like some intersections here, but we can fix. Let's do another one here, soft transform, and with this way we are like moving this part from each other, and we can do it also here, but let's this will be like pin to anim, will not be a big deal, but now this will avoid issue with the simulation, because if we start with this will always be inside of each other and it will not freely move, and this will cause us issue. Okay, let's do another version and see you. After this finish, I will be back. Okay, so the simulation is finished. I did change the resolution in the bag because I felt it's too much. I go to the bag and I reduce the image resolution to 0.01. It was 0.005, but I reduce it to 0.01 because I think this is good enough. The simulation is heavy, taking like around one and a half frame for 1.5 minute for each frame, and this is too much. We have a lot of layers and we have a good resolution, but we should optimize it to go a bit low, like 4 frames per minute, or like at least 3 or 2. But going 1 or 1.5 or 2 minutes for each frame, this is too much. So I think we can reduce the resolution a little bit, but before doing that, I will show you like the flipbook of the result, and I will talk about what is the issue and what we will do. So what I did, I add a color node, and I colored based on the path for each base and primitive. And I did a flipbook based on that with the camera like this. I also localized the motion on the origin, and I did a second flipbook so we can see both 2 different flipbooks. I will show you this flipbook. So this is the localized one. Is the result. I think the overall simulation is looking good, but we have to fix some issue. For example, the bands not looking so good. It should be fixed, and the bend stiffness should be a bit more stiff. And we have here on the back and the side panels some intersections. Let me show you in the extreme frame. Yeah, as you can see here, it's going inside each other, and this is not good. And like this frame, the gloves collide with the bag and it's like destroying it. The bag should be a bit more stiff and rigid. Not so rigid, but should be even more stiff than this because it's bending too much. And this area is also going inside the bag and it's always following the bag, so this should be outside, and I should fix it with a soft transform and try to have a gap between all of the pieces like this also, and this, because if we keep it will stay in the whole simulation following the same thing. Also we have some bad collision here, so this go inside the collider and this is not good. So I will work on these issues and fix it. So yeah, this is colliding with the back and destroying it, and this is not looking good. I will try to find which it's good to have this colliding with the back, but we should have it a bit more stiff, and maybe I will release this a little bit so it's having this area also simulating. This part of the clock is good. It's interacting good, and I think overall is looking good. But yeah, we should fix this. I will go to the second. Uh, the second flipbook. Let me run real time first. So as you can see here, this part of the clock is colliding with the shoulder armor and it's sticking to it and should be free from here. Let me show you. So this collide it's sticking to the shoulder armor and this is not looking good. It should be free movement, like until this area, for example, from here to back should be freely moving, because this is not looking good. Yeah, this is not looking good. Should be moving freely. And maybe I will add a little more velocity damping and a little bit of drag. So this is dragging behind a little bit, and this is not looking good. So I will try to work on this area and fix it one by one, and after that we will optimize the simulation and make it going faster. So with this, maybe we are gonna like keep like doing like another merge, for example, like this, and keeping the important parts and like killing the others and focusing on this part, for example. And maybe this we don't need, the armor, and this also, and doing another simulation. So we, after that, having a good result with these main layers, and then we add the other layers after, and having like because this area is not so important. Make sure we have like the bag, the cloak, and the band, the tank, all these important, and the bigger layer is looking good, and after that we can add the other layers. So this is the beauty of using like a horizontal Venom constraint method. But if you are going vertical, you can. It's hard to disconnect and connect, and it will be a bit complicated to do it. But with this way, maybe just like kill half of it and do a simulation. And if you feel this is looking good, you can go to the next one by one, and do the simulation and make sure it's looking good. Work on it, focus on it, and having it looking good. And this way you can easily debug the simulation and make sure you have no issue. Okay, I think that's it for this chapter. See you on the next one.